All right, guys. So we are jumping to chapter 10 today, sequences and series. Okay, sequences and series. Now, this whole chapter is all about these sequences and series, and what a sequence is or series, you can kind of see in the notes, right? You have like lists of numbers, and lists of numbers where there's like a pattern to them. That's what a sequence is. Okay, so we're going to be talking about how to handle these lists of numbers with these patterns. All right, and there's two main types of sequences we're going to talk about. And we're going to talk about them today. The first one is called an arithmetic sequence. An arithmetic sequence. Okay. And what makes a sequence an arithmetic sequence is that each term is found by adding or subtracting a constant value to the preceding term. Okay, so let me give you an example of what I mean by that. For example, if I had this arithmetic sequence, let's say 2, 4, 6, 8, 10, dot, 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 dot. Okay. That's an arithmetic sequence because every single time, if I want to get to the next term, I would add 2. So since we're adding 2 to get to the next term, that is that constant value. Okay? And this constant value is called the common difference. And we use D to represent that common difference. All right. So that's what an arithmetic sequence is, when you add or subtract to get to the next term, and you do the same number each time. All right, so your first formula here, this is to find the nth term of an arithmetic sequence. So like, let's say I'm looking at this sequence and I want to know, well, what's the 100th term, right? What's the 100th term? Instead of adding the 2 like 99 times to get to the 100th, to add a 99 2 99 times to get to the 100th term, we actually have a formula that you can go straight to that 100th term. And that's this formula right here. I hope I didn't break my pencil. Oh, good. All right, so this is the formula. Just so you guys know, I actually do it where I put the D in front. So go ahead and change that on your notes. Move this D being multiplied, move it to the front here. Okay. All right, so how this works is this A sub 1 represents the very first term. Okay, so that's what the subscript 1 means, right? Which term it is. So A sub 1 is the first term. D is that common difference. And N is, which term we want. So if I wanted the 100th term in this arithmetic sequence, I would plug in 2 because that's my first term. I would plug in 2 for the common difference. And if I want the 100th term, I would plug in 100 for that N. All right. So that is the formula for the 100th term. All right, and we'll be working with this, so you guys will get a little bit more of a handle on that, okay? But first, let's just go ahead and focus on how to tell when a sequence is an arithmetic sequence, okay? So let's look at number 1. Let's see if we can tell. Is this sequence an arithmetic sequence based off of what we said? So go ahead and put in the chat what you think for number 1. Do you think that is an arithmetic sequence? Yes or no? Put it in the chat. Good. Nice. Good. Nice. Good. Yes. Nice, guys. Awesome. So yeah, you guys got it. So this is yes. Oh, oops. Sorry. This is yes. It's an arithmetic sequence. And because it's yes, they want to find the common difference. So what is the common difference for number 1? Put that in the chat. Good. Yes, yes, yes. Good. Nice, guys. Perfect. Perfect. Good. Yes. So D is positive 9. Excellent. Because every time to get to the next term, we would add 9. You got it. Good job, everybody. Okay. Let's try another one. Number 2. Is this an arithmetic sequence? Yes or no? Number 2. Good, 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 good. Nice. Good, 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 good. Good, good, good. Awesome. Okay, let me call on somebody and I want you to tell me what your answer is and also why. All right, why? So let me call on Chris. You got the right answer. So you said no, and why? Why did you say no?
Um, there was nothing that could. I don't know. It's just none of them were equal to each other. Like to get to the next number.
Good, yeah, because to get from 7 to 10, what did you have to add?
3.
Good. And from 10 to 4, you would have to add. I think I heard 4. Okay. So yeah, there is no common difference. So no common difference is the reason. Perfect. Good job, guys. Okay. What about number 3? Let's see if number 3 trips you up because you see some negatives. What do you guys think? Yes or no? Good, 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 good. Nice, guys. Good, 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 good. Awesome. Okay. Liam, you said yes. Why yes? You're right.
Hello? Okay, there it is.
Okay. So you said yes. So what's the common difference?
-4.
Perfect. Nicely done. All right. We got a common difference this time. It was -4 to here to here. Good job, Liam. Okay. So we got a common difference of -4 in that case. All right. Any questions so far? In the chat. Cool. Let's continue. Number 4. Find the next 4 terms of the arithmetic sequence. All right, so I got 7, 11, 15, and I want to find the next 4 terms. 1, 2, 3, 4. Go ahead and type those in the chat. What would be the next 4 terms of this arithmetic sequence? Give me all 4 numbers. Good. Nice. 4 numbers, guys. Some of you guys give me 3. Good, Celine. Good, Michael Y. Good, Angie. Good, Netta. Good, Yanni. Good, Gloria. Good, Liam. Good, Joanne. Good, Riley. Give me one more number, though. Good, Ethan. Good, Jackson. Good, Riley. Good, Michael P. Person who put +4. Yes, that's the common difference, but I'm looking for the next 4 terms. Good, Chris. Nice. Good, Betty. Awesome. Yep. Good, Brendan. Nice. Give me 4 terms. Good, Leo. There you go, Brendan. Yep, you got it, guys. Nice, Samantha. Nice. All right, good. So you good, Joseph. Good, Paolo. Nice. Awesome job, guys. Nice. All right, so you found the common difference was 4, and then you use that to get to the next 4 terms. Perfect. All right, so these were the next 4 terms. Now they want us to graph the sequence, and I'll just do this pretty quickly. So the first term was 7. So I'm just going to plot 7. All right, right there. The second term's 11. Third is 15. Fourth was 19. 23 was the fifth one. 27 and 31. And the reason why I want to plot this was just to show you guys that this is a linear graph, right? Because we are increasing by the same amount each time, you end up with a linear graph. All right, so that's number 4. Good job, guys. Moving right along. Okay, number 5, same thing. Give me the next 4 terms. The next 4 terms. Yes, you can use the bathroom. All right, give me the next 4 terms. Ooh, good job. Nice, Riley. Good, Mateo. Good, Celine. Good, Joanne. Nice. Good, Yanni. Good. Nice. Good, Leo. Good, Angie. Good, Michael Y. Good, Liam. Sweet. You guys are crushing this. Good job. All right. So, yes, everybody that put in the chat, you got it. -9, -17, -25, and -33. All right, we had a common difference of -8. -8. All right, so if we were to graph this, the first term was +15, second term was 7, third term was -1, fourth term was -9, -17, -25, and -33. So as you can see, this gives you, and again, another linear plot. All right, which by the way, a slope of -8. Okay, good job, guys. All right, so that is your arithmetic sequence. Well done. Okay, let's move on to our second type of sequence, which is geometric. All right, so our geometric sequence here is similar, except instead of adding or subtracting to get to the next term, we multiply a constant value. All right, we multiply to get to the next term. So for example, a geometric sequence would be like 2, 4, 8, 16, 32, 64, ... Okay, so we are multiplying by 2 each time to get to the next term. All right, now this constant value, this is called the common ratio. The common ratio, which we're going to use R to be our variable. Okay. All right, and just like the arithmetic sequence, we have a formula for the nth term of a geometric sequence. And this is the formula we're going to use. Okay? All right, but before getting into that formula, let's go ahead and get used to these geometric sequences. All right, so number 6, go ahead and tell me yes or no. And actually, if yes, tell me what R is equal to. All right, so in the chat, yes or no, and if yes, tell me what R is equal to. Nice. Somebody's already got it. Nice. Good, Joanne. Good, Celine. Good, Mateo. Good, Michael Y. Good, Netta. Good, Celine. Good, Angie. Okay, all right. Good, Yanni. Good, Ethan. Tell me what R is equal to if you say yes, by the way. Well, I think you kind of gave it away. So the answer is yes. So tell me what R is equal to. Good. Yes. Yes, guys. Nice. 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 All right. Yes. R is equal to -3. Excellent job. Excellent job. So you multiply -3 each time to get to the next term. All right. Multiply -3. Multiply -3. Good. All right. Let's try number 7. What do you guys think? Yes or no? Give me the R if yes. Good, Sebastian. Nice, Mateo. Nice, Michael Y. Nice, Celine. Give me what R is equal to. Okay, good. Good, Celine. Yep, you got it. No on the 0.5. Close, though. Close. Good, Angie. Nice. Good, Tim. Yes. Nice, guys. Awesome. Good job. So, yes, the answer is yes. And R is 1/4. R is 1/4. Okay. I think the easiest way to find R is actually to take a term like 2 and divide it by the previous term. So R, you can do 2 divided by 8, and you get 1/4. Okay. So always divide by the previous term. Okay. What about number 8? What do you guys think? What about number 8? Yes or no? If yes, give me the R. Good. Oh, you guys are getting faster. Nice. Good. Good, Celine. Good, Joanne. Good, Yanni. Nice, guys. Good. Okay, I think some people are still thinking. Still thinking. Yes, no, and if yes, give me R. Good, Angie. Nice. Good. Okay. Yeah, so this one is no. Now let me show you why. Good, Riley. Nice. If I were to do R as 4/1 with these two terms, right, R would equal to 4. But if I did R again with 9 divided by 4, notice you get a different R. We need to have the same R, so that means this is no. That is not a good common ratio. So this will be no. Okay? Because this divided by this does not equal to this divided by this. They don't equal. All right, cool. Let's try one more. Number 9. Yes, no. If yes, give me R. This one's a little bit tougher. Ooh, or not. Good job. Yes, good job, person. You got it? Try not to give it away. All right, good. Nice, Yanni. Nice, Joanne. Nice, Celine. Nice, Riley. Nice. Good, Michael Y. No on 4. No on the 4. Remember, make sure you're dividing. Make sure you're dividing. No on the 4/3. Good, Gloria. Good, better. Yep. Yes, Leo. Yes, Angie. Yes, Timothy. Good. Nice, guys. Well done. Yes is the correct answer. And to find R, you can do 24/16. Divide top and bottom by 8. And you get 2/3. Double check and do 36/24. All right, divide by 12. We still get 3/2. If I divide 54 by 36, I can reduce that by 9, and I can reduce that by 3. All right, so they're all equal to 3 over 2. So r is 3 over 2, or 1.5, either one. All right, good job, guys. Any questions on that? Beautiful. All right, let's go to number 10. All right, find the next 3 terms of the geometric sequence. So they tell you that it is a geometric sequence. You need to tell me the next 3 terms. All right, so 1, 2, 3. All right, go ahead and put that in the chat. Next 3 terms. Good, Joanne. Good, Celine. Okay, so good. I think you guys found out that R is 4, in case you're wondering. What I would do is I would use these 2 terms just because I think it's a little easier than the first 2. So I would do 1 divided by 1/4, which gets me 4. All right, so since R is 4, I'm going to multiply to get to my next term. So 1 times 4 gets me 4. 4 times 4 is 16. 16 times 4 is 64. All right, so then let's go ahead and plot that. First term was 1/16, so super, super close to 0. And then the next one is 1/4, so still super, super close to 0. Next one is 1. Next one is 4. Next one is 16. And next one is 64. So as you guys can see, this graph is growing exponentially. All right, it's growing exponentially. Cool. All right, let's try one more of these. Number 11. Try it one more time. See if you can get the next 3 terms. So number 11, right? What you want to do is to find R. So R, you take 2 terms, right? I think the easiest ones would be these 2. And you put the 4 over the previous term of 20, and you get R of 1/5. Okay. So to get to the next terms, you're going to multiply by 1/5. Okay. So when you multiply by 1/5, you multiply the numerators. I get 4. Multiply by the denominators, you get 4 over 25. Okay. Do that again. Multiply by 1/5, which essentially we're just multiplying the denominator by 5. Let's multiply the denominator by 5. We get 4 over 125. And then do that one more time. Multiply by 1/5. And we get 4 over 625. All right. And that is your solution. Let me see if there's any questions about that. Good, Celine. Nice. All right. Feel free to put questions in the chat too. Let me plot these while you guys think of any questions you might have. All right. So first term, second term is at 4. So right around there. Third term is at 4/5. So it gets really small, really small, really small, really small, essentially. Yeah, once I get down to those fractions, you don't really have to be super exact. It's just like close to 0. Cool. All right, good job, guys. So yeah, we are talking arithmetic sequence and geometric sequence. So hopefully you guys are getting used to this whole common ratio and common difference thing. All right, let me show you one word problem, and I think that will do it for today. Okay. Number 12, read this one out for us, please. Maddie, can you read this one out for us?
Bricks at the bottom row and 79 bricks in the second row and 23 bricks in the third row. And how until there's only one brick in the top row.
Okay. All right. So we have basically a pile of bricks. All right. So we have something like this, and then it gets smaller and smaller as you go up until the very last row just has one brick at the very top. Okay. So
Okay.
dot, dot, dot. All right, so one brick at the top. So we know that there's 85 in this row, and there's 79 in this row, and 73 in this row, and then one brick at the very top. The question is, how many bricks are in the 12th row? All right, so if we want to find how many bricks are in the 12th row, basically we can think of this as an arithmetic sequence.
Isn't it just -6 each time?
Yep, you can definitely minus 6 each time, but there is a faster way to do it. Okay.
Yeah.
So here we notice what is the common difference? What are we subtracting?
6.
6. Good. So our common difference is 6. I want to figure out what is in the 12th row. So I'm going to use that formula from up here, this nth term circled in blue. All right. So I'm going to use that formula to find the 12th row. Okay, so let me copy down that formula down here. A sub n is equal to a sub 1 plus d parentheses n minus 1. So that's the formula, and I'm going to plug in now n to be 12 because I want to know what is the 12th term in that sequence.
Yes.
My first term is 85, right? That's the very first one. And Maddie, you found the common difference of 6, and now n,
which is 12
is
minus
12.
1.
Yep, there you go. All right, so 85 plus 6 times 11, which is 85 plus, oh, sorry, minus, I'm sorry, minus. We're subtracting
I was about
6.
to say, I was like so confused for a second.
All right, nope, you were right, minus 6. So it should be negative 6.
So -66.
There you go. And then we get 19 bricks on that 12th row.
Row.
Yep, there you go. All right, so that's how you use the formula. Okay.
Yeah.
Okay, part B, how many rows are there in all? All right, so how many rows are there in all? That means I want to figure out, well, what n is going to be if my last row has just 1. All right, so I'm going to say, well, my last row is 1, and I want to figure out, well, what row is that 1? Well, my first row is 85. My common difference is 6. And I need to figure out, well, what row is that last one where I only have 1 left? All right, so we solve for n.
Wait, do you need am I still helping with this problem or?
No, you are not.
Oh, okay, cool. It's just like, do I turn on my mic or?
Yeah, you can turn off your mic. All right, so I'm speeding through this because I know we're out of time. So this gets you 15 rows. All right, so that's how you would solve for that problem. Okay, we're gonna do more of this on our next lesson, starting next week. Remember tonight, study for the quiz. This homework isn't due until Friday. Okay, good job, guys.